Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Variational Autoencoders. VAEs. AI's imagination machine for data generation. Imagine an AI that doesn't just recognize faces, but can imagine new ones that have never existed. That's what generative AI does. Today, we're diving into variational autoencoders. VAEs, which are like an AI artist's brain. They learn the rules of data, like what makes a face, and then use those rules to invent completely new, realistic data, whether it's images, text, or even music. As developers, thinking about an AI that can create rather than just classify opens up a whole new world of possibilities. Before VAEs, let's understand generative AI. Most AI you hear about, like an app telling you if a picture has a dog, is discriminative. It discriminates between categories. Generative AI is different. It generates or creates new things. Think of it like this. A discriminative AI tells you if a cake is chocolate or vanilla. A generative AI gives you a recipe to bake a brand new cake, one that might be chocolate, vanilla, or even a never-before-seen flavor combination. For developers, this means we can build tools that design prototypes, write stories, or create virtual worlds. To understand VAEs, let's first look at their simpler relative, autoencoders. Imagine you have a giant picture of a cat. An autoencoder tries to compress that picture into a tiny summary, called the latent space or bottleneck, and then use that tiny summary to perfectly reconstruct the original picture. It has two parts, an encoder, which compresses, and a decoder, which reconstructs. As a developer, you can think of it like zipping a file and then unzipping it perfectly. The goal is just to recreate the input, not necessarily to create something new. Simple autoencoders are great at compression, but if you try to make them generate new things by giving the decoder a random summary, the results are often garbage. Why? Because the summary space, latent space, they create is often messy and discontinuous. Imagine zipping a bunch of files, and the compressed versions are all over the place. If you pick a random spot in that chaotic space, it's unlikely to correspond to a valid unzipped file. This is where the variational part of VAEs comes in to save the day by making the latent space organized. VAEs fix the messy latent space problem. Instead of the encoder just outputting one summary point for an input, like cat, it outputs a range or distribution of possible summaries. Like this cat could be described by any summary within this small, well-defined circle. Think of it like this. The encoder doesn't give you the recipe for a cat, but a recipe range * for any realistic cat. The decoder then randomly picks one recipe from that range to generate a new cat image. This ensures that the latent space is smooth and continuous, so any point you pick in it will likely generate a meaningful result. Let's break down the VAE structure for a developer. 1. Encoder takes your input data, e.g., an image, and outputs two things, a mean and a variance. These define the recipe range we talked about. 2. Reparameterization trick. This is a clever math trick developers use to sample a point from that recipe range in a way that allows the AI to learn effectively. 3. Decoder takes that sampled recipe from the latent space and tries to reconstruct the original input or generate a new one. 4. Loss functions. Two main goals. Reconstruction loss. Make sure the generated output looks like the original input for accuracy. And *KL divergence loss. Makes sure the recipe ranges are well behaved, encouraging that smooth, continuous latent space for generation. This is the variational part. Now for the exciting part. As a developer, VAEs open doors to 1. Generating new data. Create realistic but fake images. E.g., for data augmentation, new product designs, or even music. 2. Anomaly detection. If an input doesn't fit into any of the learned recipe ranges, it might be an anomaly or something unusual. 3. Data imputation. Filling in missing parts of data, e.g., repairing damaged images. 4. Latent space interpolation. Smoothly morphing one image into another by walking through the latent space. Imagine morphing a dog into a cat, or a smiling face into a frowning one. VAEs are powerful tools for creating, exploring, and understanding complex datasets. So, we've explored how VAEs move beyond just recognizing data to imagining and creating it. They take the concept of an autoencoder, add a variational twist to ensure a smooth, meaningful latent space, and enable powerful generative capabilities. For you, the aspiring AI developer, understanding VAEs means you're not just building programs that react to data, but programs that can dream up entirely new possibilities. This is the essence of generative AI, and VAEs are a foundational piece of that puzzle. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.